Honors Geometry Notes, section 11.5, completing circle squares. Well, that sounds a little off-putting. Circle squares. Standard equation of a circle, if you recall, the difference of x and h, quantity squared, plus the difference of y and k, quantity squared, where h and k are the center. This equals the radius squared. We're supposed to write each equation in standard form by completing some squares. Identify the center and the radius. Well, x squared minus 6x, we're going to group that together and try to make that a perfect square trinomial. Y squared minus 2y, we're going to group that together and try to make that a perfect square trinomial. Any constants, we're going to move to the other side of the equation. So let's move the constant over first. So equals 8. Myself a little more space. I need to make two different trinomials, perfect square trinomials. To make those, we're going to complete the square. So I take my terms that have x's in them, and I leave a space for a constant. Take my terms that have y's in them, put them in another set of parentheses, leave some space for a constant. To complete the square, if you recall, we're going to take half of b is negative 6, that'd be negative 3, and square it, that would be plus 9. If you do it to one side of the equation, well, you better do it to the other. To complete this square, we're going to take half of b, half of negative 2, that's negative 1. Square it, negative 1 squared is positive 1. If you add 1 to one side, you got to add 1 to both sides to keep the equation balanced. If we've done this correctly, and we have, this is a perfect square trinomial, this is a perfect square trinomial. A perfect square trinomial will always factor into a binomial. This first one factors into an x minus 3 quantity squared, and the second one factors into a y minus 1 quantity squared. The right side, if you add up those numbers, you get 18. Just a quick review, how do we get this binomial? If you take the square root of the first term, it goes here. Square root of the last term goes here. Sine of the middle term goes here. Square root of y squared, square root of 1, sine of the middle term. It's always squared because you're making a perfect square trinomial. This is now in the standard equation of a circle. The center is whatever you're subtracting from x, followed by whatever you're subtracting from y. So the center is 3, 1. And the radius is the square root of the constant. Square root of 18 is the same as the square root of 9 times 2, which is 3 square roots of 2. Let's do another. Number 2. Group, group. So I have x squared minus 8x. To complete the square, I'm going to take half of negative 8, that's a negative 4, square it, and you get 16. If you add that to one side of the equation, you got to add it to the other side of the equation. And I'm going to add to this y squared plus 10y. To complete that square, I'm going to take half of 10, which is 5, and square it and get 25. Add it to one side, you got to add it to the other. That makes this first trinomial a perfect square trinomial. Square root of x squared is x, square root of 16 is 4. Take the sign of the middle term, it's a difference of x and 4 quantity squared, plus. This other trinomial becomes a square. Square root of y squared is y. Square root of 25 is 5. The sign of the middle term is a plus. And then the right side, if we add these numerals together, we're going to get 51. The center, it's x minus a positive 4. And then it's y plus 5 quantity squared. That's the same as y minus a negative 5. The radius is the square root of 51. 51 is a prime number. We cannot simplify it. Identify the center and radius, then graph the circle. Alrighty, let's group the x terms have x's together, terms have y's together, and let's move the constant to the right. So x squared minus 6x plus y squared plus 4y equals 3. To complete the square of the trinomial with x's, we take half of -6, which is -3, square it, and that's 9. Add it to both sides. If we take the trinomial that has the y's in it, half of 4 is 2, 2 squared is 4, add it to both sides. So we added this 9, that's what this is about. We added this 4, that's what this is about. We've changed the way the equation looks, but we haven't changed the fact that it's an equation because we did the same thing to both sides. This perfect square trinomial factors into an x minus 3 quantity squared. And this one factors into a y plus 2 quantity squared. And the right side, 3 plus 9 plus 4 is 16. So the center, positive 3, negative 2. Radius is the square root of 16, which is 4. Finding the center, we go from the origin and we go to the right 3 and down 2. That puts us right here. Radius is 4. Let me label this. So if we go to the right 4, and if we go up 4, and we go left 4, and we go down 4, essentially you're going 4 in every dimension, two-dimensionally. It's going to give us this approximate circle. You don't have to have both of that vertical and horizontal diameter. There's number 1. Let's check out number 2. We're supposed to complete the square. So we have x squared plus 16x, half of 16 is 8, 8 squared 64, plus y squared plus 12y, half of 12 is 6, 6 squared is 36. The right side had a 91. We just added a 64, and we added a 36. Added this to both sides. We added this to both sides by completing the square. The trinomial with the x's in it is going to be x plus 8 quantity squared. The ones with the y's is y plus 6 quantity squared. 64 plus 36 is 100. 100 minus 91 is 9. The center is going to be -8, -6, and the radius is the square root of 9, which is 3. Start from the origin, 1, 2, 3, 4, 5, 6, 7, 8 left, and then 1, 2, 3, 4, 5, 6 down. Count 3 in all directions, and you're going to get a circle that looks something like this. So we said the center was -8, -6, and the radius is 3. And let's color this little fella. I believe that concludes the notes. Please do the homework from section 11.5. Thank you.